Okay, so now what we're going to do is we're going to talk about factoring. We've already discussed the basic factoring and things like that, but now we're going to go just a little bit further in depth. Before we do that, I want to review that idea of basic factoring. Basic factoring was that idea that we just kind of look for what they have in common. So if I have something that says 4x squared z minus 2x y squared, yeah, that'll work. I look and go, what do these two things have in common? This has a 4, which breaks down to 2 times 2, and this has a 2. This has x squared, and this has x. Now, this one has z, and this one has y squared, and so those don't have anything in common. But I can pull a 2x out and be left with 2xz in the first one and minus y squared in the second one. And that's the idea of basic factoring. We just look for what they have in common. Okay? Beyond that, we started doing trinomials. And the trinomials, we looked at two different ways, okay, the trinomials. We looked at the ones that just had a 1 as a coefficient, x squared minus 3x plus, let's say x squared minus 3x minus 10. And so something like this is whenever it had no coefficient right here, then what we had to do was we had to factor this and see what two factors of it add up to be this. And so in this case, it would be negative 5 and 2, because negative 5 times 2 gives me negative 10, but negative 5 plus 2 gives me positive 3. Negative 5 plus 2 equals negative 3. Negative 5 times 2 equals negative 10. I'm sorry, yeah, equals negative 10. And so that's what that factors into. And so then we just get to rewrite it in the factored form, which is x minus 5 times x plus 2. And you can write it the other way around. You could also have said x plus 2 times x minus 5, and it wouldn't make any difference because multiplication is commutative and I can multiply in any order. But then we got just a little bit more complicated. We said, well, what happens if there is a coefficient there? And that's when we did something called factor by grouping, okay? Factor by grouping is when you either have a coefficient on the front of a trinomial or you have 4 terms. 4 terms overall. You use factor by grouping. So if I have something that says, 3x squared, 3x squared minus 1x minus 10. Okay, because this has this coefficient right here, I need to use factor by grouping. So what I do is the first thing, and this is the one weird step, is you go, I got to multiply this times this, and that's the new number I'm trying to factor. 3 times negative 10 is negative 30. Okay, 3 times negative 10 is negative 30, and so therefore, I get factors of negative 30 that add up to be negative 1. And that would be negative 6 plus 5 gives me negative 1, and negative 6 times 5 gives me that negative 30. Okay? And so what I can do is I can say I split this into those two numbers, into these two values. So you get 3x squared minus 6x plus 5x minus 10. Notice the negative 6x and the positive 5x would just go back together and equal this negative 1x. That's all they would equal. And so that's not too hard. And so what I'm going to do right now is now I do this thing called factor by grouping. I pay attention to just half of it at a time, just these two terms and then just these two terms. What can I take out of that 3x squared minus 6x? Well, I can take out a 3x. Oops. I can take out a 3x. And this is where you go to your basic factoring, and that would leave me with x minus 2. What can I take out of 5x minus 10? Well, I can take out a 5, which would leave me with x minus 2. And so there you go. Here's your basic factoring. And now I've got this x minus 2 here, and I can factor that off to the front or the back. And that would leave me with 3x plus 5 times x minus 2. And that would be the finished form. Okay, I'm done at that point. So whenever you have a coefficient on the front, right here, you can use factor by grouping. Let's try one more example, just in case you're still a little rusty on these. If I say 2x squared minus 5x, so let's see here. Well, hang on, before we do 5x. How about we do 2x squared minus, no, I don't want to do that. Yeah, my brain is not liking the different numbers I'm coming up with. How about we do 2x squared minus 2x minus 15. Okay, so you start by going 2 times negative 15 gives me negative 30. Factors of negative 30 that add up to be negative 2, but then also, of course, I made a mistake here. Sorry, this was supposed to be a negative 1. Factors that add up to be negative 1, but then also multiply together to give me negative 30. But I just did those numbers. Sorry, this is lame. Okay, we'll switch it up and go, how about 2x squared minus 3x minus 14. Okay, 2 times negative 14 gives me negative 28. Factors of negative 28 that add up to be negative 3 would be negative 7 plus 4 is negative 3, but negative 7 times 4 is negative 28. At this point, you then split this into those two values, and you get 2x squared minus 7x plus 4x minus 14. You factor by grouping. What can I take out of these and what can I take out of these? On this first one, you can only take out an x, which leaves you with 2x minus 7. The second one, you can take out a 2, which leaves you with x minus 7. And so now I have x plus 2 times 2x minus 7, okay? And so some of them aren't real obvious like this one. You know, you look at these first two terms and you wanted to take out more than that, but the only thing they had in common was x. The second two terms, the only thing they had in common was that 2. All right, so now it's your turn to try it. Go ahead and see if you can do this one. We'll put a 3 on the front and say 3 x squared minus 5x minus 12. All right, so we'll pause the video right here and you guys try to factor that one. Okay, let's give it a shot. 3 times negative 12 is negative 36. Factors that multiply together give me negative 36, but when I add them, I get negative 5, would be negative 9 plus 4 gives me negative 5, or negative 9 times 4 gives me negative 36. So that's what it is. So I say 3x squared minus 9x plus 4x minus 12. You factor out the 3x, because I'm just looking at these two terms. That leaves me with x minus 3. You factor out a 4, and that leaves me with x minus 3. Okay? So then I can go 3x plus 4 times x minus 3. Hopefully these are working out pretty well for you now. All right. Now we got a couple others to talk about, okay? First of all, we have the difference of two squares. Now, we saw that when we were multiplying conjugates. When we had something like a plus b times a minus b, those were conjugates, it always ended up being a squared minus b squared. And that is the difference of two squares. And so to factor the difference of two squares, it just goes back to here. So if I had x squared minus y squared, that would factor to x plus y times x minus y. All right? And so then what we can do is if I see things that I go, wait, these are only two terms, it's a difference, and they're each some type of square, then I can factor it down to the difference of two squares. Real easy, basic example, x squared minus 9. It's two terms, it's a difference, and they're each something squared. This is x squared, and this is the number 3 squared. So therefore, it factors down to x plus 3 times x minus 3. Now this can get even a little bit more complicated. You could have something like 4x squared minus 9y squared. And you have to kind of realize that inside that 4x squared is 2x being squared minus 3y being squared. So therefore, it factors down to 2x minus 3y times 2x plus 3y. All right? Okay. So it's the opposite of the conjugates. We've already seen this. We already know this. I want you to give it a try right now. So I'm going to give you two to do. One really simple, basic, one that's a little bit more complicated. Okay? So for starters, something really basic. How about we say z squared minus 16? And something a little bit more complicated. How about we say 9y squared minus 25z squared? Okay, so we can pause the video right here and then we'll come back and give it a try. All right, here we go. So this first one is obviously z being squared and a 4 being squared. So when we factor it, we just simply get z minus 4 times z plus 4. The second one is 3y being squared minus 5z being squared. So we factor down to 3y minus 5z and 3y plus 5z. Okay. All right. We have two more kinds to look at that are definitely probably the most complicated, but they're still not that bad. These were the difference of two squares, and now we've got to look at cubes, factoring cubes. In squares, you can only do the difference. You can't ever do the sum of two squares. X squared plus 4 doesn't factor down. You know, if I say x squared plus 4, that doesn't factor down to anything. But x squared minus 4, that factors down to x plus 2 times x minus 2, because that's the difference of two squares. When it comes to cubes, you can factor both, the sum of two cubes and the difference of two cubes. So if I have x cubed minus y cubed, well, no, let's start with the sum, and we'll do the difference. It is just a formula that you have to kind of commit to memory, okay? What it is it looks like this. This is going to factor into a binomial times a trinomial. And the binomial always looks just like this, but without it being cubed. And the trinomial is the first term squared minus the difference of the two terms. The product of the two terms, minus the product of the two terms, plus the last term squared. And then when it's the difference of two cubes, again, it factors down to a binomial times a trinomial. The binomial always looks like that, and it's just this. And the trinomial is this plus the product plus the second one squared. Now here's how I remember it. I remember it in a couple ways. First of all, whatever it has here, whether it be a sum or difference, that always ends up here. Difference, difference on the first one, sum, sum. The other thing I notice is that there's always only one subtraction sign. So either you got it taken care of right from the very beginning, and so then the other two are addition, or you did an addition, and so the very next one has got to be the subtraction, and then addition, because there's only one. There's only one subtraction sign. So I know that if I had y cubed minus z cubed, okay, the first thing looks just like that. It's y minus z. The second one is the first term squared plus the product of the two terms plus the last term squared. And yet if that was the sum, it would look, the binomial would look just like that, y plus z. And then because I've already used my addition, I gotta have a subtraction. I'm gonna have y squared minus yz. Now I've used all the subtraction I need, so I go back to addition plus z squared. Okay? These are pretty simple. They only get more complicated when you've got, some coefficients and things like that. So what I want you to do is I want you to try to do 3 of these. We're gonna pause the video right here and you try to do 3. All right? We're gonna do a real basic one that says a cubed minus b cubed. We're gonna do a little bit more of a complicated one that says a cubed plus 27. And then I want, if you could try a really complicated one that says 8x cubed minus what? How about we go 64 z cubed? That would be the most complicated. Okay, so we're going to pause the video right here and you give them a shot. All right, let's take a look at these. First, I'm just going to take a look at the first two. I'm going to move this other one down a little bit to give myself some room. Okay, this first one's so easy. Remember, we said that binomial always looks like what we got, a minus b. And then we square it. It's the product of them in the middle. We already took care of the minus sign, so it must be plus plus. Okay, it's that simple. Now, this one's a little bit more complicated because I have to realize that this is x cubed, and this is also 3 cubed. So this is my first term, and this is my second term. So when I do this, I have to go, well, it's x plus 3, not x plus 27. The first term squared, x squared. At the end is going to be the second term squared, 9. 3 squared is 9. I've already used my plus, so I got to use a minus and then multiply the two. Okay? So that one might have been a little bit more complicated. I'm not sure. Some people might have gotten this part wrong here where you had to write a 3, you had to come up with a 9. And so some people will struggle with that, all right? And now let's try this last one. Okay, this last one, 8x cubed minus 64z cubed. So I have to realize that this is 2x being cubed, and this is 4z being cubed. And if I think about it that way, it's so much easier. So I say 2x minus 4z. And then I have to square that first term. And 2x times 2x is 4x squared. I have to square the last term, and I get 16z squared. And it's going to be plus plus because I've already used that minus. And the middle is just going to be the product of the two. 2x times 4z is 8xz. And it's that easy. I know it seems kind of complicated and kind of crazy, but it is not that bad. Okay, so hopefully this was enough practice. If you need to rewatch certain parts, but now we are just going to practice factoring over and over and over and over and over and over. Check your answers in the back of the book.